Yo, what's going on? All right, we're continuing on with the VT22 V4/V4 Ampegs from 1977, 78. There's two of them. This one was the first one I had. It was not necessarily modified, but there was work done. It was recapped to some degree. This other one here was a more recent purchase. It's nearly 100% intact from factory original. And today, what I want to cover is the one schematic that is available out there that is the same that's on top of these amps, and both of these amps got the same schematic date and information. There are some, well, there's an outright mistake in this schematic, and I'm going to show you where that is. It's a very bad one. If for some reason you go back in here and say, oh, this was modified, I need to put it back to this, you will make sparks fly and things will shoot out your ears if you're touching the chassis, all kinds of stuff. All right, and the other thing is there are differences in the way the boards are set up and how they're actually wired. In other words, there are some places on these boards for resistors and other connections that actually aren't made on the board. They're done elsewhere or in different ways. And there's a couple things that are actually missing compared to what's on the schematic and what's shown on the board, or vice versa. So we'll go over those things. All right? All right. Okay, so here is a printout of the schematic that you'll find online. The only one that I can find that is for the 613-1977 edition of this amp, which both these are. They have the master volume, that's one of the big discerning features, and 4 different tone shaping switches. Here is a picture of one of the amps. It has a decent, on the back of the amps, on the back of the, let me get that, on the back of the panel of these amps. This is the panel that goes on top with the reverb hanging from it. Ampeg put schematics. For a million reasons, those schematics don't hold up very well. They're paper. But at any rate, this is a picture of that last one that I just showed you. The other amp was completely destroyed. We're going to zero in on 2 different things right now. We're going to zero in on the bias circuit, and we're also going to zoom in on the filtering and the dropping resistor in particular in the A to B to C nodes and how they're wired. Okay, so let's go to the bias schematic for the bias circuit, and I'll show you on the amp also. This drove me nuts before I actually figured it out. It was bothering me that this is one of those, here's the bias circuit here. You can see the minus 62 volts, which, oopsie, the minus 62 volts, which goes up and feeds the grids of the power tubes. What you have here is from the bridge rectifier, well, it's attached at that point, from the secondary, the transformer, the high voltage secondary, there is a line that goes to a capacitor that feeds the bias circuit. But does anyone see right away? It should have been easy for me to figure this out immediately, but there is a huge mistake in this. This is a capacitor coupled bias circuit. So it's taking the high voltage from the secondary, one half of the secondary, so a pulsing DC in effect, and is going to a capacitor which then feeds the circuit. But here, this is the ground line here. If you were to look through the rest of the circuit, you'll see that is the ground connection through the amp. This is not connected to ground, nor it should be, because you would be connecting the secondary, one half of the secondary, to the ground. That does not exist, and I'll show you in the amp. So what you have is a capacitor coupled circuit that goes to a reverse diode, which gives the negative voltage pulsing here, which is filtered. Voltage divider through this. Actually, the voltage divider includes a resistor that is actually after this first capacitor. etc., and feeding up through there. So I'll show you that in the amp. Okay, let's take a look at the amp with that. Okay, this may be a little tough to see. See if I can point it out. But what we're going to be looking at is the issue with the schematic of the bias circuit. We're going to show that, hopefully I'm going to be able to show that at this point there is no connection to ground. All right, so what we're looking at here is the bridge rectifier. These are the two high voltage secondaries from the power transformer that feed the bridge rectifier circuit. One side is grounded, the other side goes to the anode. And from here, from the middle point, if you want to call it, or the feed point, it is tapped. This circuit is tapped. This rectifier is tapped to feed the bias circuit. So let's see if we can find that. So if we look in here, you can see the 4 behind this diode. Ignore these flying diodes. These diodes here on the board are the bridge rectifier. And we can see the 2 points from the power transformer where they feed into this bridge rectifier. One is connected to 2 diodes on one side, the other is connected to 2 diodes here and here. So if we look, let's see if I can get a better shot over here. From this point, okay, maybe that's a little better. So if we move these out of the way, we'll see one side of the secondary feeds 2 of the diodes and the other side feeds the other 2 diodes. You can see that there. But at this point, here where the secondary comes in, it's from the power transformer. It's also, there's a tap for the C16 capacitor. It goes all the way across to this point in the circuit. Let's see if I can get a little better shot there. At that point, so we're looking across, from here we're looking across this capacitor. We should see a diode and a resistor connected. And certainly from here we see a reverse diode and we see a resistor. Okay, so there it is. And if you follow anything else, or at this point, from this point or this point, there is no other connection, whether it's to ground. The only connections are to the 2 diodes for the bridge rectifier, the actual secondary, and then to this capacitor. So there it is. Let's take a look at the other side too of the board so you can see that there's no connections underneath. All right, this one's a little tough to see, but here is C16. You just about make it out, labeling under there. And here are the secondaries, the high voltage secondary output from the power transformer. That line there is that's not connected to this. So as you can see, so back here there is nothing else connected to this. This is, in no place is this connected to ground. It should not be. So as we were looking at that, we're looking at C16, that's the yellow one there. So it comes from one of the secondaries and goes directly to, on the other side of the, as seen on the other side of the board, goes to the rest of the bias circuit. Okay, let's take a look at the various nodes in the amp and how they're wired. The schematic is correct here. We're just looking at the first couple of nodes. We have, coming off of the bridge rectifier, the A node. So we've got a pulsing DC here. You've got one side of the secondaries being the positive here, and then when that goes negative, there's no voltage there, the other side picks up on a positive. So there's a pulsing DC that is filtered through this first series of capacitors. So we have our A node here. One side of the A node goes up and feeds the center tap of the output transformer primary. The other side of it then continues on through the rest of the amp to supply the voltages in the B plus rail. We have a B node and a C node. So at this point, from the A node, and you see this a lot in amps, you have a branch. There is a dropping resistor, a high watt dropping resistor, that then feeds the B node, which is filtered also separately through the 40 microfarad capacitors in series for a total of 20 microfarads at 900 volts. But that B node then feeds, if you were to follow the rest of the schematic, you would see that it feeds the screen resistor, screen grid resistors, and that's typical, the B node. But also from the A node, there is a separate dropping resistor, and let's zero in on this in the amp when we get to it. R53 is a 3000 ohm, or 3K ohm, 5 watt, it's listed here, resistor that drops to the C node, drops a voltage here for 400 volts at the C node, where you can see B and A are 545 and 535 respectively. So from the A node goes directly a dropping resistor to the C node, which is filtered separately. If you look here, this is the capacitor can that's on the other side of the amp. So let's take a look at the actual wiring of this. You can see it continues on to the D node, another dropping resistor, etc. Let's take a look at that and see how it's actually structured in the amp, because there's a discrepancy from how the board is designed compared to actually how it's implemented. Let me say that again. This here, although wired exactly as it's shown here, the board is constructed in a way that the R53 is supposedly mounted on the board. There's a spot for it. But as you'll see, it's actually not mounted to the board. It's mounted elsewhere. So let's go take a look at that, show you what I mean. Okay, let's see if I can show you how R53 is set up in the amp, or if you come across an intact original one of these. So let's find the bridge rectifier in the circuit. These are the 4 diodes in the bridge rectifier. This point here, can I zoom in a little bit? This point here in the circuit corresponds to the A node of the B plus rail. So this A node here, you follow the trace, goes across. One side of this goes over to the filter caps, right here, and the resistors that are in parallel with those in series filter caps. That goes around here to over here. But if we follow the A node across here, the next contact point is here, and you will see R53. So if we're looking at R53, this point here, we should see 2 different resistors. We should see R53 and R55. And if we look, if we move that out of the way, we shall see R53 and R55. So that is this point. So at one point it is feeding here to the B node and is feeding here across 53. The thing is, if you look under this board, there is no R53 in place. Because otherwise, if it was in place, you would say, okay, then this point here on the other side of R53 is the C node, which it is. And if you look, it actually says C there. And you can see there's a wire running from it. And you say, well, that goes to C. But what we actually find here, there is no resistor. Took a little sleuthing to figure it out, but what is done on the amp is, this is the A node point here. This is the top of the series. This is the 100 ohm. This is this point here, where this capacitor in series with this capacitor This is the top, this is the anode. Now this phi, if you look here, there's a line, a mystery line. One side goes to the, from here, goes to the output transformer center tap. There's another line here that comes over to the board that supplies, that comes from the actual anode, from the bridge rectifier. But there's a third line here, and if we trace that line back, it goes under the board and across. Let's zoom back out a little bit. If we follow it, we find that it comes to a post. Let's see. Let me get closer there. So once again, I followed a line that came from the filter caps, from the anode, that isn't really directly shown in the schematic. And it comes over to this terminal strip. And interestingly enough, if we look, we see a 3K 10 watt resistor there. Effectively what that is R53. Even though there's a spot on the board for R53, it is not populated. Now, my guess is why this was done is if we, let me zoom back out here and reposition. Okay, my guess why this is done is if we have the A node here, which is connected back through here and filtered at that point, what we have is the least filtered line is coming across here. And that least filtered line has a very large component. It's on the other side of this board that has the least filtered signal. It's carrying the least filtered signal right in the middle of this board, and then would go to be filtered. I think what they turned around and said is, you know what, we can eliminate some noise or some hum from interference from the AC signal that's on that less filtered anode. And instead what we're going to do is we're going to run a line, that anode line that's the least filtered. We're going to run it away from most things next to the chassis, and we're going to bring it all the way back here. Then we're going to drop it and filter it. Then it'll come back to the board. So actually this is a return in a sense for the C node, where if this resistor was in there, that would be sort of the send. Electrically it doesn't make any difference, but what you have is then you have the component that has this large component that's carrying the least filtered DC component of the B plus rail is all the way down here out of harm's way as opposed to the middle of the board. So that's why I think they did that, and that's one of the biggest things that you'll see in this amp that are different than what may, or different than what it seems like it should be. So there you go. All right, so let's take a look. I just removed the cover. These amps are really, I love the way these amps are set up to be able to work on them. You can get to each side of the board. Everything is numbered and labeled. It's got its own sort of little stand. By the way, I had to rebuild this. This is a new piece. I used the screen that was there. Anyway, I digress. I usually do. So you can see here, and it's clearly labeled on both sides of the board, which is great, that R53 doesn't exist on the board. It exists, but it is tied down at the other end of the amp by the preamp stages, the filter cap down there, the filter cap can. There it is. So that's a quick one here. I just wanted to cover those things. You can come across these amps and say, wait a minute, I don't understand, what is that resistor? You may not look under the board to see that R53 is not actually there, and you're thinking that there's an additional component, another 3K resistor there, because on the schematic it says 5 watt, and it is a 10 watt. And this, interestingly enough, the space is large enough for at least a 7 watt, and they used to make them then, or a 10 watt. So there it is. hope that helps. I hope that dispels any confusion that you may have. If you have any questions, just let me know. I'm here to help you out as much as I can. You may be helping me out.